Hello. In this video, we're going to go through the graphing of y equals 4 secant x plus 3. And I'm going to start out by drawing it a little bit imprecisely, but enough so that you can most likely choose the correct answer among multiple choice possibilities. But then I'm going to continue on and show you how to be a lot more precise if you need it. Okay? So, first, I just want to remind you about asymptotes and the basic shape of y equals secant x. So if you recall, here, secant x is, or secant of an angle, is defined as 1 over x, and because you have a variable in the denominator, if x can be 0, then you have an asymptote, right? So where is it that x could be 0? Well, x is horizontal motion. So where is it 0? Here at pi over 2, right? Coordinates are 0, 1. And here, I'm going to write negative pi over 2, even though you probably know it as 3 pi over 2. But because we're going to be graphing on a number line, I'm going to be starting here and going there. So, but at negative pi over 2, the coordinates are 0, negative 1. So of course, when you're on the unit circle and your radius is 1, when you take 1 divided by 0, you're going to get an asymptote. Now, it really wouldn't matter what size circle you have. It could be 5, 10, whatever your radius is, divided by 0 is still going to be an asymptote. Okay? So here then, when we go to graph y equals secant x, here 4 secant x, what we want to actually graph is y equals 4 secant x plus 3. That's what we're really graphing, right? But what is it related to? Well, it's related to cosine because the reciprocal of cosine is secant. And the reason I want to bring that up is that if you graph the cosine wave, the secant wave, in a sense, rides on the cosine wave. So if you remember cosine, and you're here and you're saying, okay, I have a new horizontal axis up at 3, y equals 3, so I'm here. So this would be y equals 3. Then normally with cosine, what you would do is you would start here from your axis, it actually would start at 0, 0, and you'd go up 1, and then come down here to negative, and then come back to positive. But here, we're starting at a new axis, so if I were pretending to graph just regular cosine with a coefficient of 1, I would start here up at 1, and then at pi over 2 come down to the axis, and then at pi come down to 1 below the axis, and so on. But you have 4 cosine x. So the fact that we're starting up here at this axis, y equals 3, takes care of this plus 3. But I still have to look at the amplitude. So from here, I'm going to go up 1, 2, 3, 4. I'm going to be here. And so then I'm going to come down. And at pi over 2, I'd be at the axis. And then I'm going to come from the axis, I'm going to come down for 1, 2, 3, 4 here at pi. And then I'm going to come back up to the axis. And finally at 2 pi, be up here. So technically, one cosine wave would look like this, right? And I'm putting it as a dashed graph because it's not really part of the secant graph. It is just a helper guide. So what would happen is if you put together the asymptotes that we found out, since the graph we're looking at has no horizontal effects or changes, we can just put the asymptotes at pi over 2 and negative pi over 2. So let's go ahead and do that. And then actually every multiple of pi over 2, because what's happening is if you're starting here at pi over 2, then if you go pi, you have another asymptote, rotate another pi, you have another asymptote, rotate another pi, you have another asymptote, and it doesn't matter what direction you go in. So it's going to be, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and in the negative direction, the same thing, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on and so forth. So there's where your asymptotes are. And so on and so forth. And now what you do is you draw in your secant. It's actually going to fit between the asymptotes, right? And this is the 0.07 here. This is going to go down. And this is just going to keep alternating, right? So on and so forth. Now, this point here is pi negative 1. And you just keep going on. So there's going to be 2 pi 7 and so on and so forth. Okay. Now, this is actually enough for most people. Okay, this right here. So if you're looking to just answer, like I said, which is the correct multiple choice graph for something like this, this is good enough. What I'm going to continue now is talking about, well, what if I need a little more precision? Because I just kind of drew this up. How do I know if maybe this opens more widely or more narrowly? That's what I'm basically addressing. Where's the precision if I need it? Okay. So what I do then is I look for what I call anchor values, and my anchor values are x values. Okay. And I happen to use pi over 3 and negative pi over 3 because I want to work with stuff that's easy to compute, right? So what do I mean by that? Well, I end up getting 2 and well, later on negative 2. So that's pretty easy. I don't have any square roots. I don't have any fractions and when I do, they're very easy fractions, right? So what I did is, because I know the unit circle and I know the coordinates, I know that at pi over 3, secant is 2, right? It's 1 over x. There's my x value. So when I take the reciprocal, I get 2. And here at negative pi over 3, same thing, I get positive 2. Now, that means that when I substitute now, what I call anchor values, what I'm really working with is this equation for secant x plus 3. So now when I substitute in pi over 3, right, then I know that the secant of pi over 3 is 2. Now I just do 4 times 2 is 8 plus 3 is 11. Okay, so that way I get these points. Right? I have, well, I guess I had 0. That was kind of nice because it was just ends up being 7 because I end up having 1 times 4 is 4 plus 3 is 7. But basically I have my asymptotes at negative pi over 2 and pi over 2. And now I just found my anchor values and what those y values, the x values, which are the anchor values, and then plugged them in, got the y values. And so I'm plotting all these points. So in general, I think this is enough. You have the anchor values, of course, are going to be your asymptotes. You always got to have your asymptotes, negative pi over 2 and pi over 2. So I figure out what x value will give me negative pi over 2 and pi over 2. So we're going to do a more complicated example next. But in this case, since I just have secant x, it's pi over 2 and negative pi over 2. And then I use 0, which is that center value here. And then I use negative pi over 3 and pi over 3. Oh, it should have been positive here. So that I have a little bit of precision about how widely or narrowly this is opening. Okay? So there's that first part. Now we may say, well, okay, great, you have one part of the U, but if you remember, the basic shape of secant and cosecant is 2 U's. One's opening upward and one's opening downward, right? And the period is 2 pi if there's no horizontal effects. So how do I get the next, what I'm calling U? Well, if I look at the distance from negative pi over 2 to pi over 2, right, then I would say end minus beginning. That is, the difference is going to be this distance here from negative pi over 2 to pi over 2. And essentially, when I say pi over 2 minus a negative pi over 2, I'm really getting 2 pi over 2 or pi. So that means that if I want what is the corresponding anchor value here, I would just add pi, right? And essentially I'm going to have that U opening downward, and when I plug in the value that I get into the secant equation, I'll get the point I'm looking for. So if you look at negative pi over 3 and you say, okay, I'm going to add pi, so I'm going to be here. Well, that's going to give me 2 pi over 3. And if I add pi to 0, I'm going to have pi. And if I add pi to pi over 3, I'm going to get 4 pi over 3. Okay, so let's go ahead and plug those in. So what that means is, and I went ahead and showed you on the unit circle, here's your values that you know. At secant of 2 pi over 3, you know you get negative 2, and secant at 4 pi over 3, you get negative 2 also. and at secant at pi you get -1. Now when you evaluate these anchor values into the specific equation that we're dealing with, I now am going to use this -2 times 4 gives me -8, plus 3 is -5. Same thing here. And then at pi, it's you got secant of pi is -1, but now it's being affected here vertically, so times 4 is -4, plus 3 is -1. So what that gives me finally, then I put it together, we had this first part, and now we're having this second part, and I know where this is located, right? I go over 2 pi over 3 and down -5, over pi and down -1, over 4 pi over 3 and down -5. And remember, your asymptotes are all pi apart. So this is one, shall we say, wave of the secant, and then it just continues on indefinitely, right? It's like a little rubber stamp. You just keep going, in both directions, positive and negative. Okay. Now, a couple things I want to mention. Why did I choose the anchor values of pi over 3 and basically multiples of pi over 3? It's because if I had chosen another anchor value for secant, for example, if I had chosen pi over 6, then I'd get some pretty ugly values to work with, right? So at pi over 6, remember this is square root of 3 over 2 for the x. So the secant of pi over 6 is 1 over x on the unit circle. So 1 divided by square root of 3 over 2 gives me 2 over square root of 3. And then if I rationalize it by multiplying by 1, so I get the no radicals in the denominator, I have 2 square root of 3 over 3. How nasty is that? So when I go to actually plug it into this specific equation, I'm saying, well, 4 times secant pi over 6 plus 3. Well, that's 4 times this nasty stuff plus 3. Very, very messy. And if you recall, these were much cleaner, right? You just plug in 2 or -2. That's why I picked those specific points or specific anchor values, okay? And the last thing I want to talk about is how do I graph this in my calculator, okay? So, into y equals, I'm going to put, now here I kind of simplified this a little, 4 secant x plus 3. Remember, secant x is 1 over cosine, and then you multiply 4 times 1, so it's 4 divided by cosine, right? So I'm going to put that in, 4 divided by cosine, and then here's my x, right? X, and I'm going to close it. I'm closing it so that the 3 isn't included as part of the input to the x, and as part of the input to the trig function, all right? So there we are. Now, if I just do, for example, zoom 7, which is zoom trig, let's just see what the calculator does. Takes it a little while to do its thing. So what's happening, if we look at what I had, let's go back and get that. Oh, I know it's behind here, sorry. What you'll see is you're missing the top because it's not in your window. So what you can do is say, okay, I'm going to go maybe from negative pi over 2 is like negative 1.57, right? It's pi is 3.14 divided by 2, so a little over 1.5. And so I might go, let's say, negative 2 radians to positive 2 radians. And by the way, make sure you're in radian mode. And then I might go here from, let's say, negative 10 or negative 15 in the y value to maybe positive 15 or something like that, and just see what that looks like. So I'm going to go to my window, and I'm going to go to negative, let's say, 2 radians to, let's say, well, let's see, this is 1.5. Let's go to 2 pi. Let's go to 2 pi. So I'm going to say 2 pi. And then this is saying I'm going by pi over 2, right? 1.57. And now here I'm going to go from negative, let's say, what the heck? Let's go negative 20 to 20 and just see what we get. So now I've got to press graph because I'm setting the windows. There you are. Now you're seeing the upward opening U's. Right, there you go. All right. Now, of course, this goes on infinitely. And between these, right, is an asymptote. Between each set of U's is an asymptote. Now let's just see. Let's put in, let's say, negative pi over 3 and see if we get 11. So let's just double check it. To do that, you're going to go second, we're wanting to access calc, and we want to choose value. So we can either press 1 or enter. And now I'm going to put negative pi divided by 3, and there it is, 11. All right, so you can check yourself. And let's check something like here, 2 pi over 3. Okay, so at 2 pi over 3, we should get negative 5. Let's just check that. All right, let's go to the value. So we're going to say 2 pi divided by 3, and there is negative 5. All right, well, I think that's it. Thank you so much for listening. If you need this kind of precision, this is how you do it. Thank you so much.